Hello, everybody. Welcome to the Quadrilateral Note page. So originally I was going to have you write in all these properties as we went through, and I was like, boy, that was really, really time consuming. So I went ahead and typed them in for you, and we're just going to go through and kind of look at what each one means and annotate the pictures a little bit to help us see the different properties of different quadrilaterals. So quadrilaterals are four-sided shapes. And then there's five or six specific ones that we're going to be looking at today. So parallelogram is our first one. And a parallelogram is defined by having opposite sides that are parallel. So like these sides are parallel and those sides are parallel. I wonder where the name comes from. And that's what those little arrows indicate. One arrow with one arrow means those are parallel. Two arrows with two arrows mean those are parallel. And I kind of showed the different types of arrows that you might see on each one. Also, another property of them are that the opposite sides are congruent, meaning that this side isn't just parallel, but it is equal to that side, and this side is equal to that side on a parallelogram. Opposite angles are also congruent. So this angle is congruent with this one that's diagonal with it over there, and this one is congruent with this one right there. So opposite angles are congruent. Now, on the right-hand side over here, I felt like it'd be too much to put all in one picture. So these are the properties about their diagonals. Once you have a parallelogram, you can do stuff with the diagonal, specifically saying that consecutive angles are supplementary in a parallelogram. That doesn't have to do with the diagonal. I shouldn't have put that over here. That part actually belongs over here, saying that this angle plus this angle always equals 180. So those are supplementary. Same thing with these two, or with these two. Those would also be supplementary. So consecutive means right next to each other in a row, they add up to 180. So opposite are equal, and consecutive are supplementary. Now, the diagonals bisect each other, meaning that this line cuts these two pieces in half, and this line cuts these two pieces in half. So it's not saying that this is equal to that. It's saying that these two parts right here will always be equal, and these two parts right here will always be equal. And we could actually go back to our parallel lines chapter and prove all of those properties if we wanted to. But moving on, rectangles. So rectangles, all the angles have to be right. That is the definition. That's the part that defines a rectangle. From that, we can also assert that the opposite sides are parallel. So we could say that this side is parallel to this side, and that this side is parallel to this side down here. So opposite sides are parallel. And again, we could prove that because these both form 90-degree angles and those both form 90-degree angles. So these must be parallel if they both form 90-degree angles to the same transversal. Opposite sides are congruent. So we also know about a rectangle that this side equals that side and that this side equals that side. Now, diagonals. The diagonals are also congruent. So this whole line right here is congruent to this whole line right here. And the diagonals bisect each other. So we can go one step further and say, in this case, all parts of the diagonals are congruent. This equals this. This equals this. This equals this. And this equals this, all the way around, right? Every one of these little parts of the diagonal are congruent because the lines are both congruent and they both bisect. That means they cut all of the pieces in half, and if they were equal, then the halves are also equal. So some properties about rectangles there for you. Now, a rhombus kind of looks like a parallelogram, except the idea with a rhombus is that the opposite sides have to be congruent, right? Up here, they didn't. So they just had to be parallel to each other. Obviously, these top and bottom lines are not the same length as the side lines. Here, they have to be in order to be what's called a rhombus. So we're kind of creeping up on the idea of squares, right? First, we say lines have to be parallel. Then we bring in this idea of 90 degrees. Now we're starting to say, all right, opposite sides are also equal, or all sides are also equal. So we know a few things from that. Opposite sides are also parallel. So this, again, is parallel to this. And these are parallel to here. So opposite sides are parallel. Opposite sides are congruent because all sides are congruent. If opposite sides are congruent, actually all sides are congruent. Consecutive angles are supplementary. So again, that's back over to this idea, pulling from the parallelogram, that these two angles are supplementary. And these two angles are supplementary. The diagonals are perpendicular. So this is a new one we haven't seen yet. The diagonals don't just bisect each other, but they actually form 90-degree angles. That's a new thing we haven't even seen with rectangles or anything else yet, is that the diagonals form 90-degree angles because they're perpendicular. And they bisect each other. So this equals that, and this equals that. But you'll notice again, the diagonals don't have to actually be equal, that this is a longer distance than this is right here, so that the diagonals aren't necessarily equal on a rhombus. Which leads us into the creme de la creme, the square, the one that's got it all going on. All angles are right angles. Opposite sides are parallel. Boop, 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 boop. All sides are congruent. That's what the little tick marks show, that they're all equal sides forming 90-degree angles and opposite sides are parallel. And from that, then, we can start talking about basically everything we've seen before with the diagonals. The diagonals are congruent. So these sides this diagonal is equal to that diagonal. The diagonals are perpendicular because a square is also a rhombus. And the diagonals bisect each other. So that means that this is equal to that, and this is equal to that, and all four parts of the diagonals are also equal. So that has really just like everything going on. So these kind of build on each other. These are all sub quadrilaterals that kind of build up to a larger, the most specific quadrilateral. The square has all of these properties. It has to have opposite sides congruent, right angles, opposite sides parallel. If you have all of those things, you have a square. But if you only have some of those things, you have these other shapes called parallelograms, rectangles, and rhombuses. Now, trapezoids kind of flip the script. They get a little weird. We go back to the idea that we only need, or not back to, it's the first time we've seen where we only need one set of parallel lines. So when you have one set of parallel lines, you're going to get a trapezoid. So these can be any angles. You could make them parallel, or you could make them not parallel. You could make this one go way out here, or even cut in here. As long as you have one set of parallel lines, you have a trapezoid. Now, an isosceles trapezoid is what we're used to kind of seeing. And that's where we only have one set of parallel lines, but those other two lines are congruent. They're the same length. They're not just like this weird kind of thing. There's not a lot we can really do with just a normal trapezoid. But isosceles trapezoids have some properties that we can utilize. So the sides are congruent. These two sides right here are congruent. These obviously aren't, the top and bottom, but the sides are. That means the diagonals will also be congruent. So that makes these two shapes or diagonals, these two lines be congruent. With a trapezoid, we can then kind of use, I was going to cut this out because I don't really know why anyone would do this, but it's a thing. And as I started looking through problems for this chapter, this theorem pops up all the time. So I'm like, all right, I guess I'll tell them about it. If you've got a trapezoid and you take the bottom length and the top length and you average them, that will give you the length of the midpoint. Or more specifically, if you know that E is the midpoint of AB and F is the midpoint of CD, then you would know that this length is exactly half of those two lengths added together. Right? It's weird. I don't understand why it's really something we need to talk about, but hey, there it is. If it comes up, you know what to do now. It's a thing. I saw it on a lot of SAT practice stuff. So there you go. That's the trapezoid midpoint theorem. It's if these are midpoints, then that length is exactly half of those two being added together. Yeah? All right. All right. Kites, our last one. And then we can start using some of these properties. Please don't feel like you need to memorize this. I'm just giving you a bit of an overview, and you can always reference back to this. This is stuff that is a tool for you. The only time you need to memorize any of this or kind of internalize some of it is, I guess, for the SAT, but not for a test or anything like that. You can always use this page. So a kite is, again, kind of weird. We don't talk about parallel lines or even really like all sides being congruent or anything about angles. What we are concerned with here is that consecutive sides are congruent. So if you have two sides that are the same length and two other sides that are the same length and those equal lengths are next to each other, it always makes this shape, this kite thing. So two pairs of consecutive congruent sides. And we also end up with one pair of opposite congruent angles. So that is specifically these angles right here. These two angles don't necessarily need to be equal, but these two always will be. If the sides, we have two sets of consecutive congruent sides, that'll make these two angles always be equivalent. or congruent. From that, we can draw a few things about their diagonals. The diagonals form a perpendicular angle always in a kite. If you've ever seen an actual kite, that's how the supports are laid out, right? And a perpendicular angle. One of the diagonals is bisected. So if we kind of look at it for a second, this definitely isn't cut in half, right? This side is longer than that side. But this one here, there's a property that can be proved showing that those are congruent, that diagonal is being bisected by the other diagonal. So one of the diagonals is bisected, and it's kind of hard to talk about which one without introducing like A, B, C, D, and I didn't want to get that detailed. So you have to use a little bit of judgment when you're looking at this about one of the diagonals, the one that looks to be bisected is bisected. That's not a good way of doing geometry, by the way, of just like, it looks like, but in this case, it's kind of the easiest way to talk about it. And then the diagonals create 4 right angles, which we already saw. That if that's a right angle, then that's a right angle, that's a right angle, that's a right angle. So it's right angles all around, baby. Okay, so let's start putting some of this stuff to work. If you'd like to try to pause now and go ahead yourself, this would be a good time. I'm going to go through the first couple, and then I will ask you to pause and try to finish it out. So this one says here, the perimeter, first off, we have a parallelogram. That's the symbol for a parallelogram. And if we know this is a parallelogram, then we can use all of the properties that we looked at back here on parallelograms. So if I want to find the perimeter of a parallelogram, well, I only have 2 of the sides. I don't know what AB and AD are, but I have a property that tells me that the opposite sides are congruent on a parallelogram, which that kind of makes sense. Right? This side is the same length as that side, and this side is the same length as that side. So to find the perimeter, then I just add all those numbers up. 10 plus 10 is 20, 24, so 44 would be our perimeter if we added 10, 12, 10, and 12 all together. I'll do one more before I ask you to pause. CT equals 9, then AT equals. So if CT is 9, then AT is how much? Well, let's go back to our properties and see if we know anything about the diagonals of a parallelogram. Hey, diagonals bisect each other. Hey, that's convenient. That tells us that this is the midpoint of AC. So if that's 9, then the other side is 9. So we're just putting those properties from the front side to work for us and seeing what new information we can derive. We'll use this later in proofs, but for right now, I'm just trying to get you familiar with how some of these things work. So if you haven't already, go ahead and pause the video and try number 3 and 4 on your own. All right, hopefully it took a little bit of time to work through that. So looking at the next one, if CDA equals 60, so CDA, so if this right here is the whole angle, CDA is 60 degrees, then CBA, the opposite angle would also be 60 because we saw from the front side that opposite angles of a parallelogram are always equal. And furthermore, BAD, that bad angle, is supplementary. So this plus that have to equal 180. Well, 60 plus 120 is how you would get 180. And then finally, AT equals CT. And we have 2 different equations. But if we know again that that is the midpoint, if this bisects, we can set those equations equal, solve for x. So I added x, added 7, divided by 5, and got that x was 4. All right, at this point, go ahead and pause and try to finish the rest of the page. See if you can do numbers 5 through 11 on your own, and then I'll pop back in and go over some stuff. Just as a heads up, down here towards the end, you're going to need Pythagorean theorem to work out some of these, because if you remember from kites, we get right angles. So when you go to find those diagonals, you're going to be working out some Pythagorean theorem stuff. Yeah, fun, boy. Go ahead and pause and work through some of that stuff right now. All right. So I'm going to roll through this pretty quick or as fast as I can. Up here on a rhombus, we know on rhombi, that all sides of a rhombus have to be equal. So if one side is the square root of 6, then they're all the square root of 6. So I just wrote it as 4 square root 6. That's 4 times with this thing 4 times. But if you wanted to round that as a decimal, it'd be about 9.8. PQ and QR. Well, P, Q, and Q, R. Again, all sides are equal, so we can set those two equations equal and solve for x. I added x, subtracted 7, divided by 4, got 2.5. Here we have PSM. PSM is 22 degrees. Then RSM, well, we had to look back to rhombi and see that the diagonals actually bisect their angles. So this angle is equal to that angle right there. Those angles are equal. So if that's 22, then I knew the other one was 22. And we knew that the adjacent angles, or what do you call those? The in a row, consecutive. That's the word. Sorry, consecutive angles are supplementary. So this angle plus this angle has to equal 180. These two together are 44. So 180 minus 44 says that this whole angle SPQ has to be 136. And then finally here is that if PMQ is equal to that, what is the value of x? Well, you had to remember that it forms a 90-degree angle. So that means this equation equals 90. Add 5, divide by 4, and you get 23.75. All right, moving on down to your kite. Well, on a kite, we've got a 95-degree angle here, and it asks about the other side, XYZ, XYZ. Well, the opposite sides of a kite are equal. So if that's 95, then that's 95. WT and TY, so WT and TY, again, we know that bisects, so those have to be equal. I set the equations equal, solve for x, and got 3. And then the fun one, if WT is 4 and TZ is 3, we've got a 3, 4 right triangle. I need to find the hypotenuse. So 3 squared plus 4 squared is 25, and then if I square root, that leaves me with WZ is equal to 5. If that's 5, remember consecutive sides, that also has to be 5. Then I can use the 4 and 10 because it tells us that TX is 10. So I do another Pythagorean theorem with 4 and 10. 4 squared and 10 squared is 116. The square root of 116 is about 10.8-ish. So that means these two sides are both 10.8. And if I add all those sides together to find the perimeter, 5 plus 5 plus 10.8 plus 10.8, you get about 31.6. Woo! Fun with quadrilaterals. Yay! All right, you guys got some practice to do. As always, email me, message me, do whatever you got. Let me know if you need help.